Welcome to CTE Carbon Composites. As a new brand, a lot of you may be asking yourselves, why choose CTE Carbon Composites over our competitors? Our parent company, CCYS High-Tech International Company Limited, responsible for R&D and manufacturing, was established over 5 decades ago and is one of the largest manufacturers of OE chassis and friction components in the world, with a gross annual revenue over $60 million. Our partner company, M Factory Competition Products, responsible for R&D, marketing, and distribution, was established over 2 decades ago and is one of the largest manufacturers of aftermarket drivetrain components in the world, with a gross annual revenue over $10 million. By combining the resources and decades of knowledge from both companies, this puts us in a strong position to establish CTE Carbon Composites as a dominant player in the consumer-grade composites market. Due to the low market penetration of carbon ceramic brakes, cost being the primary factor, there has yet to be an officially established terminology for the various manufacturing processes of the discs. Because of this, there's a lot of overlap and confusion between CCB and CCM. While carbon ceramic brakes are more commonly abbreviated to CCB, the term CCB is also used to refer to a type or manufacturing process of the disc. The same applies to CCM. In terms of manufacturing process, the 2 main types are CCB. These discs consist of an inner core constructed from a ceramic material reinforced with carbon fiber, CFRC, which then have an additional outer ceramic friction layer added. These are the original type of carbon ceramic brakes and are very prone to premature wear and cracking caused by either surface damage to the friction layer or by oxidation of the friction layer caused by high temperatures. Of course, poor manufacturing methods and quality control also contribute to premature wear. If you notice a carbon ceramic brake disc with surface cracks, even on a brand new disc, stay well clear of it. CCM. These discs are manufactured from a fully 3-dimensional matrix of CF, RC, and do not have an additional outer friction layer. Depending on the manufacturing process and type of materials used though, an additional outer coating may be applied. These are much less prone to oxidation caused by high temperatures, but may still suffer from premature wear and cracking caused by surface damage. As with the CCBs, if you notice a carbon ceramic brake disc with surface cracks, even on a brand new disc, stay well clear of it. Although carbon ceramic brakes are touted as offering the epitome of track performance, short of carbon-carbon F1 brakes, where they really shine is on a street car, even with previous generation CCB and CCMs. Why? Not only do they have a higher coefficient of friction, meaning they will stop your car faster, when paired with the correct pads, i.e. CCB friendly, they will literally last you a lifetime without ever having to change your brake discs or pads again. Unlike traditional iron discs and pads, which exhibit frictional wear, carbon ceramic discs and pads do not wear in the traditional sense. Instead, when brake companies refer to wear on carbon ceramic brakes, they are referring to the rate of oxidation, i.e., when oxygen reacts with carbon, the carbon vaporizes. Fortunately, this process only really happens at very high temperatures, temperatures unlikely to be reached on a street car. Low temperature equals no oxidation equals no wear. As a bonus, you also get virtually zero brake dust. The downsides, cost aside, being the #1 complaint. One of the most common complaints is a lack of cold or wet weather performance. This really only affects the first generation CCBs, Porsche, Audi, Lamborghini, BMW M, Aston Martin, which have an additional silicon carbide surface layer to protect the inner carbon ceramic core from debris. Although highly resilient to frictional wear, unfortunately, once this protection layer gets damaged, rocks, debris, etc., it is very easy for the rest of the layer to crack or disintegrate. Left unchecked, this is a disaster waiting to happen. For a brake disc to perform as intended, the surface needs to be as smooth as glass, not broken into pieces like a cracked ceramic tile. Whilst there are aftermarket services available to refurbish these CCBs, for example, rebrake, by adding a new silicon carbide surface layer, the process and technology to do this actually weakens the carbon ceramic core. Carbon is what gives the disc structural integrity. The rebrake resurfacing technology actually replaces some of the carbon with silicon carbide, changing the predetermined carbon to silicon ratio from the manufacturer, leaving you with a shiny as new disc on the surface, but is weaker internally, at around $1,000 per disc. It is cost-effective in monetary terms, but at what cost in terms of safety and longevity? The jury is out on that one. The takeaway from this? If your CCB or CCMs, whether brand new or used, have surface cracks, be extra vigilant. Cracks, no matter how insignificant they may seem on the surface, allow oxygen into the disc core. And we all know now that oxygen is the enemy of carbon ceramic brake discs under higher braking temperatures. When the cracks spread, and they also affect the structural integrity of the disc. As mentioned, these are touted as the epitome of braking performance, and they are, to a certain extent. While oxidation would rarely occur under street driving conditions, when used on the track, this is a whole different ballgame. Extremely high temperatures are a common theme with track use. Remember all those images of glowing brake discs? And carbon ceramic brakes heat up extremely fast. High temperature equals oxidation equals wear. This unfortunate situation is why most non-professional drivers, i.e. less disposable income, would swap out their CCBs and CCMs for iron brakes. It is not because of lack of performance. This is indisputable, no matter how much sellers of iron brakes will argue against the fact. It is because they can't afford to keep replacing their carbon ceramic brakes after they wear down. Introducing the next generation of CCMs. Credit is given where credit is due. And for that, the shout out goes to Surface Transforms. They changed the carbon ceramic brake industry almost 2 decades ago. Using new cutting-edge technology at the time, they managed to get rid of almost all of the disadvantages plaguing the previous generation CCB and CCMs by introducing continuous long carbon fiber instead of the much cheaper discontinuous short carbon fiber used and still used to this day by Brembo SGL and thus OEM, and utilizing next generation production methods. Not only are their discs much more resilient to oxidation, hence can be used at high temperatures seen under track use, they are also much more resilient to damage. In addition, a bonus effect of the newer technology is an even higher coefficient of friction. Win-win. Fast forward to now, and almost all carbon ceramic brake discs on the market, besides the outdated Brembo SGL OEM products, are next generation, stemming from the technology that Surface Transforms developed and introduced. Yes, even the bargain basement mainland China discs. The differentiating factor between current next generation discs. Production process. Whilst all manufacturers use chemical vapor infiltration, CVI, and graphitization to create the initial 3D CFRC, i.e. carbon-carbon, and then reactive melt infiltration, RMI, to deposit the liquid silicon material into the CFRC, the differentiating factor is the technology used to achieve these production processes. Unfortunately, Surface Transforms is still using the same technology today that they first pioneered 2 decades ago. This has allowed the next generation of manufacturers, such as CTE Carbon Composites, to leapfrog them in the production process. significantly lowering both lead times and production costs. Grade of carbon. Whilst most manufacturers use T300 grade carbon, the most commonly used grade in the automotive industry, we at CTE Carbon Composites are unique in that we use T700 grade carbon, used almost exclusively in the high-precision commercial and military aerospace industries. Until now, that is. T700 has an oxidation rate of less than half of T300 and, when used in continuous fiber multidimensional matrix form, i.e. CCM, is virtually impregnable by oxygen due to the higher density, even on the disc surfaces. Being over 40% stronger than T300 also means it is much more resilient to damage caused by rocks and debris. This is why our discs can be used with zero issues by professional rally teams. Quality control. This is where the majority of the bargain basement mainland China discs fail. Even though they use the same production process, the technology used to achieve this process varies between manufacturers, as does the quality control. At CTE Carbon Composites, our proprietary technology allows us to precisely control the siliconization process, RMI, allowing a 100% uniform material structure with zero defects, zero air pockets, and zero microfractures. Surface transforms are the only other manufacturer with the ability to achieve this. In summary, this is why CTE Carbon Composite brake discs are superior. All our brake discs are CCM, thus are much less prone to premature wear and cracking. We use continuous, long carbon fiber, thus can be resurfaced 3 to 4 times over the lifespan of the disc. We use T700 grade carbon fiber imported from Toray, Japan, thus do not require to surface coat our discs, as our discs less brittle and are smooth by nature. Dynamic test simulations on our in-house Ariba brake dynamometer ensure optimum performance under all conditions. We have achieved 90% vertical integration, which means all of our consumer-grade products benefit from economies of scale due to our OE automotive and governmental aerospace contracts, i.e. Our competitors simply cannot compete with us on price. All of our bells are machined from forged 6066, T6 aluminum, not the cheaper 6061, T6 as commonly used by our competitors. We use our patented fastener mechanism, consisting of larger M8 bolts, not the common M6 used by our competitors, forged from stainless A4-70 grade steel. We are the only carbon brake disc manufacturer actively pursuing TUV certification of our discs. We hold a vast amount of ready stock of our disc cores covering 290 to 440 millimeter sizes, whilst all of our aluminum or steel, depending on application. Bells are custom made to order with a 1 to 2 week lead time. Thank you for watching this introduction to CTE Carbon Composites. If you have any questions or would like further information, please don't hesitate to contact us. Visit our website at www.ctcarbon.com. WhatsApp us on +1 909 569 4095. Have a great day.